Hello friends, in this video we will see the moment of inertia of symmetrical eye section about the x-axis axis and y-y axis, which is centroidal axis. So we will see the numerical based on this. The numerical statement is determine the moment of inertia of the symmetrical eye section shown in figure about its centroidal axis x-axis and y-y. So this is the figure. So its width is 200 mm, total height is 250 mm, and this flange height is 50 mm both sides, and web thickness is 50 mm. Now here asked in the numerical is a centroidal x-axis axis and centroidal y-y axis. So before going towards to calculate the moment of inertia about the centroidal x-axis axis and y-y axis, so we have to find here the first centroid of this section, symmetrical eye section. So how to find the centroid? Centroid is denoted here the x bar and y bar. So how to find the x bar? X bar is summation of xa divided by summation of a. So to know the how to find the centroid, you can refer my previous video of centroid. So again we can simplify it, and again or another way to find the x bar is a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. Now we'll see the what are the a1 a2 a3. These are this entire eye section divided into three parts, that is a1 a2 a3, or three areas. We'll see the in next step. Similarly for y bar is summation of ya divided by summation of a. In another way, that is a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. Now we will see the how to divide this entire eye section, and parallelly we will see the what are the things required to calculate the x bar and y bar. So here a1 a2 a3, these are the three areas. So you can see in the diagram, this is a dotted line to divide this first area a1. Then area for this is 200 mm width and 50 mm height, so that is 10,000 mm square. Similarly a2 area, this web is the second area a2. So a2 is 150 mm height and 50 mm web thickness, that is 7,500 mm square. Then a3 area is 200 mm width and 50 mm flange height, so that is 10,000 mm square. Now next step is to find the x bar. X bar is to this entire eye section divide in such a way that these are the standard shapes, means either there is a rectangle or triangle or circle. These are the standard shapes. So here we have, or with us there is a rectangle, that is a1 a2 a3. These are the rectangles. So rectangle centroid, we know the how to find the rectangle centroid is its center of rectangle is nothing but the centroid of this rectangle. So first here x1 distance is find from the left edge, that is x1. So this is 100 mm. Total width is 200 divided by 2, that is 100 mm. Then similarly for the a2 area, x2 is from the left edge distance to the centroid of this rectangle, that is also 100 mm. Then third one a3 area, that is x3, that is 100 mm. Now next step is to find the y distances. So y1 y2 and y3 for the a1 a2 a3 area respectively. So first one y1. So this is the centroid of rectangle or area a1, g1. So this distance from the lower edge, that is y1, and this is the total height is 50 mm. 50 mm divided by 2, that is 25 mm. Then next step is y2. So centroid of a2, that is g2, distance from lower edge to the this centroid, that is y2, and y2 is total is 250 mm. Height is there, 250 divided by 2, 125. Then next step is the A3 area, y3 distance. So this is the G3 of centroid of this A3 area, and distance from lower edge, that is y3, that is 225. Take the multiplication of this x into A1, then x into A2, x into A3 respectively. So these are the values of is this 1 into 10 raised to 6, 7.5 into 10 raised to 5, and 1 into 10 raised to 6. Similarly, take the multiplication of A1 into y, A2 into y, and A3 into y. So take the multiplication of these are the values you can see. Now after that, next step is here, take the summation of this area. If you see the x bar equation, that is summation of x into a divided by summation of a, means take the addition of these all areas, because this entire I section is divided into 3 parts, a1, a2, a3. So we have to take the addition of this. So addition of area is, there is 27,500. Similarly for summation of x into a, x into a is, this is a 2.75 into 10 raised to 6. Then similarly for the y into a, take the addition of this, that is 3.43 into 10 raised to 6. Now put all this value in this above equation, that is x bar and y bar, and find the x bar, y bar. So first we have to calculate here the x bar. Put all values a1, a2, a3 and x1, x2, x3 in this equation, and then take the division of these two values, and after simplification we'll get the 100 mm is the x bar. Similarly for the y bar, that is after putting the all values of a1, y1, a2, y2 and a3, y3, and take the division of this, after simplification we'll get the 125 mm y bar. Now next step is to locate the centroid of this symmetrical I section. So for that, we'll see here in front of you is I section. This is the centroid of this I section. This is the x bar distance, and x bar value we know, the already we have to calculate here the 100 mm, and y bar is the 125. So this is the location of centroid. Now next step is to find the centroidal axis of centroidal x-axis axis and centroidal y-y axis. Now how to draw the centroidal x-axis axis and centroidal y-y axis? Just draw the one horizontal, this line which is passing through the centroid. It is called as centroidal x-axis axis. Similarly for the centroidal y-y axis. That is. Now next step is to find the centroidal axis moment of inertia. So once you mark the x-axis axis and y-y axis, then go for the centroidal axis moment of inertia. So first here we find here the I-axis. I-axis is centroidal moment of inertia about the x-axis axis. So how to find this? This is the using the parallel axis theorem here. So parallel axis theorem is, you can refer my previous video, moment of inertia. In that there is I mentioned the parallel axis theorem. So here these three areas are there, a1, a2, a3. So for each area, so each moment of inertia, and then take the addition or summation of this all moment of inertia. So first is the I-axis1 for the a1, I-axis2 for the a2 area, and I-axis3 for the a3 area. Then apply the parallel axis theorem, that is Ig1 plus a1 yc square plus Ig2 a2 yc square plus Ig3 a3 yc square. So Ig1 is what? Moment of inertia of this rectangle. So G1 is the centroid for the first area, G2 second area, and G3 third area, and Ig1, Ig2, Ig3, these are the moment of inertia respectively a1, a2, a3 areas. So we know the moment of inertia of rectangle, that is bd cube by 12 plus a1 y bar minus y1 square bracket square, then plus BD cube by 12 plus A2. Then take the y bar minus y2 distance. This whenever you take the centroidal moment of inertia about the x-x axis, then take the y distances, and whenever you take the centroidal moment of inertia about the y axis, then take the x distances. Remember this one. Okay, so next is the Ig3 plus, that is BD cube by 12 plus A3 y bar minus y3 square. Just take the subtraction of y bar minus y1, y bar minus y2 and y bar minus y3 bracket square. Then put the all values. So BD cube by 12, B for the first section A1, B is width 200 mm into height is 50 mm divided by 12 plus area A1, that is 10,000 into y bar. Already we have calculated here, the y bar is 125 minus 25 bracket square y1. Okay, plus BD cube by 12 for second area, that is 50 into 150 cube divided by 12 plus area A2 7500 into y bar is 125 minus y2 is 125. Okay, bracket square plus for third area, width is 200 and height is 50 cube divided by 12 plus 10,000 A3 area into y bar is 125 minus y3 is 225 bracket square. Okay, after simplification of this, we'll get the Ixx is 2.182 into 10 raised to 8 mm raised to 4. This is the centroidal moment of inertia about the x-x axis. Similarly for the y. So here, whenever you take the y centroidal moment of inertia, then take the x-x distances. So as previous one, that is apply the parallel axis theorem, Ig1 plus A1 yc square plus Ig2 plus A2 yc square plus Ig3 plus A3 yc square. So BD cube by 12 plus A1 x bar minus x1 square plus BD cube by 12 plus A2 x bar minus x2 square plus BD cube by 12 plus A3 x bar minus x3 square. So put all values. So here B width for the first section is 50. Remember here is 50 into 200 cube divided by 12 plus area A1 10,000 into x bar is 100 minus x1 distance is 100 bracket square plus width for the second area is 150 into depth is 50 cube divided by 12 plus A2 area is 7,500 into x bar is 100 minus x2 distance is 100 again bracket square plus width for the A3 area is 50 and depth is 200 mm. So divided by 12 plus 10,000 area A3 into 100 minus 100 bracket square, that is x bar minus x3 bracket square. So after simplification, we will get the Iyy is 6.82 into 10 raised to 7 mm raised to 4. So in this way, we can calculate the symmetrical I section centroidal moment of inertia above the x-x axis and centroidal moment of inertia above the y axis. Okay, thanks for watching. So we will meet in next video. Thank you.